welcome back to another video, everyone. Happy Tuesday, and we're jumping into a new unit today, which is linear relations. So we just kind of dealt with functions and relations. That was all about graphs and the kind of characteristics of graphs and relations and all of that. And then what we're jumping into is specifically linear relations, which is a straight line. Okay, so we'll talk about a few characteristics of it. We'll talk about the equations, and we dive into a few things. This unit will take us about 3 weeks probably to get through, and then we'll move on to the next one. So with that said, let's jump into our first lesson for linear relations. Right on. Here we are, page 519, jumping into linear relations. So you might notice we're on already lesson 4. Yeah, 1, 2, 3 are not important. We're kind of jumping around to, the important parts of this unit and the things that actually are relevant. So in the workbook, it's actually 2 chapters, but we just consider it 1 unit. So I'll pick and choose the lessons that we actually need to focus on. Okay, so slope of a line segment. There's a little blurb at the top talking about, a trucker driving up a hill, or when you're building a roof, or a skier going down a hill. And we're talking about steepness. Well, in math, when we talk about steepness, we use slope. And you may remember this from grade 9. There's a linear relations unit in grade 9 where you touch on this, but not a whole bunch. And what we're going to do is take that grade 9 kind of understanding of linear relations and really dive into it and focus on the equation side and the slope side and lots of stuff like that. So, slope of a line segment. Okay, the slope is how I measure the steepness. And it's a ratio or fraction of rise over run. So you can see that right here. Okay, the rise over the run. And what I mean by rise is, okay, so from one point to another, how much did I go up between those points? And then run would be, how much did you go over? So if I had 2 points like this, okay, that are diagonal, I would talk about the rise is how much I went up, straight up, and then the run would be how much did you go over, straight over, okay? Whereas the actual line travels this diagonal, the way I would describe the steepness of that diagonal is with slope, which is the rise over the run, okay? A couple important things. If the rise is positive, that's when we're going upwards, okay? A positive rise is going up, a negative rise is going down. I think that's kind of common sense. Up is positive, down is negative. In terms of run, it's like a coordinate plane. Towards the right would be positive, towards the left would be negative, just like on a grid. As I travel right, I get bigger positives. As I go left, I get more negatives, or on a number line. Or you could think of it like reading a book. We read towards the right. Okay, that's the positive way. All right. Here are a bunch of line segments. We are going to calculate the slope of those lines, and we do that by finding the rise and finding the run. Okay, so line segment AB. Well, first thing I'm going to do is find those points. Here's A, here's B. They are diagonal. What I'm going to say is to get from A to B, I would have to go up 2. 1, 2. So that would be my rise. And I go up, so it's positive. And then I'm going to travel to the right. So it's positive. 1, 2, 3, 4, 5, 6, 7. So my slope would equal 2 over 7. Okay, and what I'm going to write is m. Okay, and here's something. The letter we use to represent slope is m. Okay, why? I don't know. Mathematicians are a little bit weird. Okay. It's the letter we happen to pick, just like y and x are the ones we use for, points and grids and all of that. Slope is m. Okay, so instead of writing slope, I'm just going to write m. CD. Okay, let's do that one. This one's a little awkward. From C to D. So it's asking me to go from C to D. That's the order it wrote it in. So I'm actually going down. Okay. From C to D, you go down. You go down 1, 2, 3, 4, 5, it looks like. So -5. And then the run would be 1, 2, 3, 4, but I'm going backwards, so -4. So my slope equals -5 over -4. Well, a negative divided by a negative is a positive. So I should just reduce that to 5/4, the positive fraction. Okay. EF. Find the slope of this one. Point E at the top, F at the bottom. Looks like I'm going downwards. 1, 2, 3, 4, 5 down. So my rise is -5. And I'm going over 1, 2, 3. +3. It's going towards the right. So my slope, -5 over 3. Okay, -5 over 3. Something to consider, this will come up later, and it's just a good reminder. We talk about this in grade 9 quite a lot. Okay, if I had the fraction -5/3, that's the same as saying it's -5 over 3, or that's the same as saying it's 5 over -3, right? If I have a negative out front or on top or on the bottom, it's all the same. That's just interesting to consider. That'll come back later, so I just wanted to touch on that. Okay, let's move on. Investigation number 1. It says investigating the slope of line segments. Okay, write the slopes in simplest form. Okay, so if I have a fraction, I always reduce my fraction. That's nothing new. And what it's looking at is, look at line segment AB, AC, AD, BC. And then it asks, how are they related? Well, something to point out. So AB, that's kind of just the first chunk. And then AC is just a little bit longer. And then AD, that's the whole thing. And then BC would be a chunk in the middle. So just a little maybe hint is, okay, I'm looking at this whole line segment, but I'm calculating the slopes of specific sections, and we're going to see how they compare. Okay, I'll do the first one, and then I'll tell you to pause and go ahead of me. So AB, from A to B, my rise is 2. You go up 2, you go over 3. So your slope would be 2/3. And I just barely have enough room to squeeze my fraction. Okay. AC, I'll do 2, and then I'll let you go. AC, okay, this is a little bit harder. You go up quite a bit. Hard to draw your arrow. 1, 2, 3, 4, 5, 6, 7, 8. I go up 8 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up 8 over 12. So that would be as a fraction 8 over 12. And then it says always reduce. And you'd say, okay, well, 8 and 12 are both divisible by 2. I could start there, I guess. I get 4/6. And then you say, oh, they're divisible by 2 again. I get 2/3. Or maybe I started reducing by just dividing by 4. Okay, great. Now I will tell you to pause. Find the slope of A to D. Find the slope of B to C. And then I want you to maybe talk about the connections between all those slopes. So go ahead and pause.
A few minutes later.
All right, so I went ahead and got the slope of AD and then BC. And what I noticed is they reduced down to 2/3. Started as 10 over 15. That reduces as a fraction to 2/3. 6/9 reduces to 2/3. Okay, so then it says, how are they all related? Well, they're the same, right? I got a slope for all of these line segments. I got a slope of 2/3. They are the same. Okay, which lets us kind of make a statement and it makes us or allows us to get a general rule, which says if I have a line, okay, the slope of this line is never going to change. So if I want to find the slope of the line, I find the slope between any 2 points. Okay, it doesn't matter if they're at the very end or in the middle or right at the start or, halfway through. It's a straight line. The slope of a straight line is never going to change. Okay, I just need to find the slope between any 2 points on that line, and then I'll know the slope of any section of that line. Okay, and that's kind of what it says below. The slopes of all line segments on a line are equal. So if I use slope equals rise over run, for any 2 points, I'll find the slope of that line. Okay. Investigation number 2 says, I got these grid 1, grid 2. Okay. Determine the slopes of all the line segments in grid 1. Then determine the slopes of all the line segments in grid 2. And then complete the following statements. Okay. All right, let's do grid 1. Okay. Grid 1, I'm looking at rise over run. Okay, m equals rise over run equals. And I notice grid 1, those are all flat lines. Those are all horizontal lines. Okay, they go straight across. So A to B, I have a rise of 0. I don't go up or down. I go perfectly straight over. And I run 1, 2, 3, 4, 5, 6, 7, 8. Well, 0 divided by 8. Pull out your calculator if you want as a reminder. Oh, it's 0. Okay. And then you think, well, what if it was a different run? What if it was, I don't know, C to D is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11? Yeah. 0 divided by 11. Oh, still 0. The other one has a run of 1, 2, 3, 4, 5. 0 divided by 5. Still 0. And then you kind of remember, oh yeah, if I have 0, 0 divided by a number is still going to be 0. 0 split into 8 groups, well, you get 0. 0 split into 11 groups, you get 0. 0 split into 5 groups, you get 0. So for a horizontal line, I don't have a rise. It's 0 divided by something. I'm going to get an answer of 0. Okay, so completing the statement below, horizontal line segments have a slope of 0. That's good to know. That's really useful. If I ever have a horizontal line instead of a diagonal, it's got a slope of 0, which kind of makes sense, right? It's a flat line. You'd say, does that hill go up or down? No, it's flat. It has 0 steepness. Okay. What about grid 2? Okay, well, this one's a little bit tougher. Okay, let's look at maybe I to J. And, okay, well, slope equals rise over run. Well, this is different. This does have a rise. It's 1, 2, 3, 4, 5, 6, 7. But the run, well, this one, there's no run. Okay, it's just they're straight on top of each other. You didn't go side to side at all. And then you say, okay, well, what's 7 divided by 0? And I think about that for a sec. And then I go to my calculator and I try that. 7 divided by 0. Oh, and my calculator tells me error. Divide by 0. It doesn't give me an answer. Well, that's because you cannot divide by 0. It's not something that exists. Dividing by 0, okay, is a non-real number, okay, or, okay, I would say the better way to say that is it's undefined, okay, undefined. So I cannot divide by 0. The definition of division is split into this amount of groups, right? 4 divided by 2 is you take 4 things and you split them into 2 groups. 14 divided by 7. You take 14 things and you divide them into 7 groups. 7 divided by 0, I can't take 7 things and then split it into 0 groups. There has to be an amount of groups. So I can't divide by 0 as much as I'd want to, as much as I'd like to try. With our definition of mathematics, it is impossible to divide by 0, so that thing would be undefined. Okay? And it doesn't matter. I go through all the other ones, right? From G to H, it would be 10 divided by 0, still undefined. From K to L, it would be 13 divided by 0, still undefined. A vertical line segment has an undefined slope. It is so steep that I can't even talk about how steep it is. Okay? Horizontal, slope of 0. Vertical, slope of undefined. Okay? Those are really, really, really important to remember, because I wouldn't really calculate them I could kind of show similar work to this, but it's something that I can recall and I'll just have instantly. Okay, investigation number 3. Going to talk about positive and negative slopes. Okay, in each line on the grids, they pass through at least 2 points with integer coordinates. Calculate the slope of each line. Remember, rise is positive. Yeah. We know that. Positive, negatives. Okay. So I have grid 1 and I have grid 2. And I'm going to calculate the slopes. So for grid 1, line 1, it's my job to find 2 points that it perfectly goes through. So as I look at this line, I'm not going to pick the endpoints because they're just hovering in the middle of my grid. That's no good. Okay, that doesn't work for me. But I might pick this point right here, right? That is perfectly, I call it in the crosshairs, right? It lines perfectly on the grid. It lines up perfectly. And then maybe I pick, I don't know, this one down here. Okay. And then from those points, I can say you go up 2, you go over 3, rise over run, your slope would be 2/3. Okay. From one point to the other, I go up 2 over 3. Okay. Fantastic. Line 2. All right. Well, I'll find 2 points. Maybe this is a good point down here. And then you kind of follow the line. Oh, maybe right here. Okay. Well, they're separated quite a bit, but I go up 1, 2, 3, 4, 5 over 2. 5/2. Okay. And then line 3. Okay. So I'm going to let you do 3, 4, 5, 6 ahead of me. And then maybe we can make a claim about some of these slopes and maybe complete the statements down below. So pause the video and go ahead of me.
A little longer than a few minutes later.
Okay, here we go, all filled in. I got a slope of 1/3 for number 3. And then on grid 2, I got -2/3, -5/2, and -1/3. Okay, and you can see the points I use and my little arrows. So maybe pause and make sure you got the same ones. So what kind of statements could we make? Okay, compare the slopes of line 1 and line 4. Well, line 1, I was +2/3. And line 4, I was -2/3. Line 2, I was +5/2. Line 5, I was, -5/2. And then I had 1/3 and -1/3. Okay, so comparing the slopes, I'm not going to write it, I'll just talk about it. I would say, well, they're the same slope, but then negative, positive. Okay, and then if I think about that a little further, if I'm looking at this like reading a book from left to right, in grid 1, they all go up left to right. Okay, some steeper than others. But what I would say is as I travel across the grid, my lines are going up. And those were all positive slopes. But then going down on grid 2, left to right, those all go downwards. Varying steepnesses. But all of those negative slopes are slanted downwards. Okay, and that's a statement I can make. It says a line which rises from left to right has a, positive slope. And then a line that falls from left to right would have a negative slope. And this is great to know. This allows me to recognize things really, really easily. If I see something going up, positive slope, going down, it would have a negative slope. Okay. And that doesn't mean that the steepness is any different, right? I can think about a roof, like all of these examples we just looked at, right? Positive going up, negative going down. If that's the roof of a house, no matter which way I'm climbing, it's the same steepness. It's just which direction am I talking about? Am I talking about the going upwards or talking about the going downwards? Okay. All right, let's get rolling here. Let's get some actual questions with this slope. So first one, it's got this picture, kind of hard to look at, but that's fine. A grid has been superimposed on a sketch. All right. Estimate the pitch, which is the slope of the roof to the right of the worker's head. All right, well, maybe zoom in so I can get a better look at this thing. So they are talking about this roof. Okay, so I guess this is a pretty good line. That's the same slope as the roof, or maybe this one up here. Those, I would call those parallel lines. Well, I need to find 2 points on that line, and I'm going to go with this one. Okay, just maybe it's easier to see than all of this with the tree or shadow or whatever that is. So I'm going to find 2 points. Okay, I would say right here looks like a pretty good point. And maybe up here, or maybe even if I went backwards, maybe down here. Those are 3 points that look to me like they're on the crosshairs. But here's the thing. It doesn't matter. I can pick any of those points on the line, and I know it represents the slope of the whole thing. So to me, it looks like you go upwards 1 and over 3. So I would say the slope is 1/3. Okay, and that's because I'm kind of looking this cross section here, up and over. It then says, could the grid be used to estimate the pitch on the roof the worker is standing on? This one, no, it cannot. We got to remember that this is a 3-dimensional shape. And if I look at this grid, it's because I'm looking at it from that flat perspective in that 2D, just kind of up and overs. Whereas this roof is like sticking out of my grid. Okay. It doesn't fall into the right plane. I'm not looking at it from the right perspective. So no, and then I kind of explained it. I won't write it down. Okay. Next one, draw a line segment on the grid, which passes through the point -4, 2, and it says slope of -2/3. The line segment must be long enough to cross both x-axis and y-axis. Okay. Write the coordinates of 3 other points on the line segment which have integer coordinates. Okay, great. First thing I'm going to do is plot that point, -4, 2. There it is. And then if I look at the slope it gave me, okay, it says -2/3. Well, here's where that could mean the 2 is negative or the 3 is negative. That all means the same thing. And to be honest, it really doesn't matter. But what I know is that's a negative slope, so it definitely needs to fall, or it definitely needs to go downwards as I look left to right. It has a negative slope, okay? And what I also remember is m equals the rise over the run. So what I'm going to do is I usually just make the rise negative, okay? I could make the rise negative or the run negative. If I'm dealing with a negative slope, typically I look at this example, -2/3. So from my original point, I'm going to rise -2, which would be like falling 2, and then I'm going to run 3. And there would be another point. I go down 2, I go over 3. Hey, there's a point. From there, I could repeat the process. I go down 2, over 3. Would you look at that? I have 3 lines, 3 dots already, okay? And I could keep that going as long as I want. Okay. As a general rule, I only need 2 points to make a straight line, to make a line. Okay. As soon as I have 2 points, I connect them and then that's a line. I say my general rule is I prefer to have at least 3, and then I know that they're all lining up. Because if it's 2, maybe I made a mistake on one of them. But if it's 3 and one of them doesn't line up, I know something's wrong. Okay. Let's do one more. Keep going and keep going. Okay. So all of those are lining up. Those are all in a perfect line. If I wanted to go back the other way, I can also fill this space. And that would be with this. You rise 2, but then you go backwards 3. So it's the same slope. I'm just working the other direction. Up 2, backwards 3. 1, 2, 3. There's another one. Up 2, backwards 3. So depending how much space I have on my grid, I might choose to go one way or the other. Okay, let's pick some points there. So for -4, 2, I also had -7, 4. And I also had -1, 0. And I also had 2, -2. Okay, and then a bunch of others, but it asked me to list 3 points. Okay, and now let's connect them. Okay, let's actually draw this line. So this is where I'd get out a ruler or, the side of my calculator, some sort of flat edge, and connect those lines. And then I know if this is a line, I ran out a grid, but this thing goes on and on forever. And the way we show that something goes on and on forever is arrows. Okay, I put arrows on either side, and that says, hey, this line goes on forever. I just don't have enough space on my paper to show it. Okay, so that's graphing with a point and a slope. It's one of the best ways to graph is, okay, throw this one on the grid, and then get my next point by counting rise and run. All right, final question. Yeah, final question, then I'll send you for some homework. Okay, it says, a line segment has a slope of -5/7 and has a rise of 12. Calculate the run as an exact value. Okay, well, if this thing is equal to slope, right? M equals -5/7. That's what that statement is saying. And I typically, if I'm given a negative slope, I typically choose to write the top number, the numerator, as negative. Okay, and it also says right here, rise equals 12. Okay, well, I know slope, or M, equals rise over run. That's an equation I know. That's a fact that I know. And what it's saying is your reduced slope is -5/7, but I want to know if I had a rise of 12, what would that be? Well, I'm setting up an equation and I'm going to solve algebraically. Here's -5/7, that's M. That's what I'm going to plug in over here. Okay. Rise, 12, that's what I'm going to plug in over there. And then run, let's call that X. Let's call that my variable. Okay. So -5/7, that was M. Rise is 12, run X. I want to know that. I want to find it exactly. Awesome. Well, -5/7 equals 12 over X. I can solve this equation. This is a proportion. Okay, we solved these when we did trig. We would have done a little bit of this. Okay, we've seen these before in the past. You'd see these in grade 9. When I have the variable on the bottom, I'm going to cross multiply. Okay, which means the things they cross from each other, the things diagonal from each other, I multiply those and they are equal. So -5x, -5x equals 12 times 7. Well, 12 times 7, not 2 times 7, 12 times 7, 84. Great. And then you say, well, I could solve this. It's cross multiply and then divide. I divide by -5, divide by -5, x equals, okay, 84 divided by -5 would be a negative answer, 84/5. And it says it is an exact value, so maybe I write the decimal or maybe I just reduce this fraction. Okay, I'll rewrite it up here. I know it's negative because a positive divided by negative is negative. Then you say, okay, well, how many times does 5 go into 84? Okay, how many times does 5 go into 84? I believe that happens. Well, I don't know. I could try 10 times. That gets me to 50. So it'd be a little bit more than that, right? 12 times gets me to 60. 14 times gets me to 70. 16 times 5 is 80. Hey. So 16 times it perfectly goes in. That got me all the way up to 80. And 4/5. Okay, I'd have 4 remaining. Realistically, this is probably an acceptable answer. An improper fraction is probably fine at this level. -16 and 4/5 is my reduced fraction. Or maybe I just actually divided and I got -16.8. So since this is a terminating decimal, it's an exact value, but you never know. Maybe I asked for the improper, maybe I asked for the reduced fraction, maybe I asked for a decimal. It's all the same answer. It's just setting it up differently. So if I ever give you the slope, and then I'm asking for a specific situation, I set up my equality, I plug in the missing value, and then I would solve, right? With a cross multiply and divide or something like that. Alrighty, that is it for this first lesson on slope. So we learned about slope today. We're actually going to dive into it a bit more in tomorrow's lesson, and then we'll be moving on to more and more with linear equations. Okay, so page 523, 1, 3, 4a, 6a, and 9 is your homework for today. And there it is, the first lesson done. Make sure you do the homework. Make sure you ask some questions in the form, set up a one-on-one appointment, all of that, and we can get through. And yeah, that's it. That is the slope of a line. And smash the like button, hit subscribe, all of that. Tune in again tomorrow.